Sometimes people frequently used Hashmap in their program. So during interview, many times interviewer used to ask, can you please explain how Hashmap internally implemented in Java? So in that cases, candidate need to write the custom implementation of the Hashmap. So let's discuss this problem today. So custom implementation of the Hashmap means that you need to write the code how Java has designed the Hashmap. But before going that, let's understand how Hashmap actually works. So this is my one hash map that I've created. So as you can see, we have the key as a string and the value as an integer. And as we all know, we have the two standard functions in hash map, that is put and get. So in the put, I pass the key as a string, that is, let's say you can assume it as some kind of age. I'm passing it as a key and the value is 21. So this will store the value into the hash map and then I will perform the get operations. So in the get operation, I just pass the key and I will get the value of it. So this is the two operations that mostly happen into the hash map. But in these operations, put and get, we always have two internal operation that is involved, which is common to both of them, that is hash code and equals. So even if you are performing the put operations or you are performing the get operations, always these two instructions executed. So let's try to understand what this two instruction actually does in the hash map. Consider this is my hash map. So here you can assume it as a value as an integer and the key as an integer and the value is the object of this class, which has two members, key and value. So the value is the object and the key is the integer. So let's say when you perform the put operations, so what it does, this put operation actually store the value into the hash map. But how it stores? It internally calls these two functions, hash code and equals. So once it call hash code, the job of the hash code is to return the index of this table where I'm supposed to store the value. So this is one table, or you can assume it as some kind of array list. So when you perform the hash code operation, you will get the particular index where I need to store my value. So that's where I use the hash code. And the equals is like out of all these nodes in this index or the bucket of this table, every object key actually represents the same index of this table. So that's why if all of these keys actually represent the same index of this table, so I need to select the unique one. So for that, I use the equals method. So what it does, equals method, out of all these objects, it actually compares the keys and whichever matches, it returns that object. So in the put operations, we use the hash code to find out the index in the table and equals to find out that specific object which actually is my desired object. So all these objects actually represent the same index of this bucket. But out of this object, I need to select my desired one. So that's why I compare all the keys value and there we use the equals method. Similarly, in case of get also, I need to get the value from the hash map. So in case of get also, I call hash code and equals method. Hash code will give me the particular index into this specific table. So let's say it returns this particular index in this table. And then the equals is actually compares out of all this object, which is the desired object that user need. So again, I use the equals method to compare the actual keys and return that object. So these two operations always use in case of put and get. But if as I need to implement the custom implementation of the hash map, so that's why I need to implement this put and get operations, because internally we generally always use these operations. But what Java does internally, that I need to implement that in this particular program. Let's understand the put operation with the help of code. So this is my code here. So as you can see, I've created one class entry and it's a generic class. So that's why I pass K and V. And it has the three members here, key, value, and next. So this key is nothing but some object key. It can be any object, it can be integer, string, or any other object. That's why I use the generic here. Similarly, other member is a value, which can be anything. And then the third member is next, which is actually the reference which pointing to the object of the same class here. So that's why it's an object of the class, the entry itself. And then this is my constructor where I pass the two arguments, which is actually the key and value, and the next is always null. So basically whenever I create an object of this class, it always points the next as a null. So this is my class entry here. And then I created one array. So this is my array. And individual index of this array is actually the object of this class entry. So I'm talking about this particular array. You can assume it and some kind of table also. It's an array An individual index of this array is actually represents the object of this class entry itself. So it means it must have a three arguments: key, value, and the next. And whenever I create an object of this class entry, the next will always be null. And then this is my object. So this is basically the object of this class entry here. So as you can see, I passed the key as some key1, value as some value1, and then next is null here. So individual index of this class is actually the object of this class entry itself. And this is my put operations that I need to perform. So in this put operations, here I am calling one function called bucket index for key. So this is another subroutine that I'm calling here. So this function is this one actually. Just for the space constraint, I written this function over here. So let's try to understand this put operation, how it actually works. So let's say as my program starts, I call this function put here. And let's say I pass key as key1 and value as value1. So these are the two arguments I passed in this put function when I call put operation first time. As soon as I call this function, it first calls this particular subroutine, that is bucket index for key. And here I pass the key, which is actually key1 in this case. So let's say this is some key 1. And then here I called my hash code function, which will basically return some hash code, some value in the hash code. It can be any value. So let's say this value will be 32, assume it for the time being. So basically I use the hash code function and apply that on key1, and let's say it returns some value. It can be any value, so I just assume it's a 32 value. And then I perform the modulus operator here, where I pass the length of the bucket. So the length of the bucket in our case is actually 16. What it means? The length of this array table is 16 here. So I perform the modulus operator with 16 and it will return 0. It means it returns the index of this table where I supposed to store the key1 and value1 here. So as I already explained, this hash code function is basically used to find out the index of this table. So by using this, I convert that into some kind of hash code and then perform the modulus operator. It can return any index. Let's say in our case, I assume it returns the index 0. So as soon as it returns the index 0, so this is become 0 here. And then I pass this bucket 0, this is actually 0, into this entry. Initially, for all the indexes in this array is actually null. So this entry is nothing but null here. So this is actually null at the first time when I call it. So it won't go inside if, because of course entry is not equal to null. And then it go inside a else statement and create a new object of the class entry. And it passed here key1, value1, and the next is of course null here. And it store that into the bucket 0 index. So it means it store that here in the index 0 positions. I pass here key1, value1, and the null here. So that's how it actually performs the put operations here. Let's see few more examples. Let's say I pass some value, let's say key2 and then value2. And again I call this put operations. So first time it call again the bucket index for key, it pass it here, let's say key2, and then again I pass it here key2, and then it's called the hash code method. Of course it can return anything, any numbers it can return. It depends on implementation of the hash code. So let's say in our case it returns 64. So again I perform the modulus operator with 16 and it will return 0 here. It means again I need to store that object into the index 0 of this bucket. So this value becomes 0, and then this is my bucket 0, so I put that value into this entry. So basically my entry is right now pointing to the index 0 here. So this is my entry. Now entry is not equal to null. In previous case entry was null, but as we already have an object here, so that's why entry is not equal to null. So we go inside this and then we try to check whether the key2 is equal to key1 or not. So entry.getKey actually returns the key1, and then I compare that with current value of key, which is key2. So of course it's not equal, so it won't go inside the if, and then it go to the else if. Here entry.getNext return null, and then we create another object, and this object actually pointed out by this one. So this entry.setNext actually create one object for you, because as you can see you have new function here. So we created a new object of this class entry and then put the entry.next to this new object. So now this one is pointing out here. So now I perform the second put operations here. Let's take Few more example to understand this put operation completely. So I call this put operation third time, and here at that time I pass key 3 and value as value 3. So it call this function bucket index for key and pass here key 3. And for the timing, please assume that let's say this will return 34 here. And then I perform the modulus operator with the bucket length. So this will be actually 16, so it will return 2 here. It means 0, 1, 2, 3. So I need to store that object into this second index of this bucket. So of course it won't go inside the if in this case, because the second index of this bucket is at the starting of it is a null. So it won't go inside it, and then it create a new object here. So my new object is key 3, value 3 and null. So how it happened? Because of this new function. So this new will going to create a new object of this class entry, and then it assign it to the index 2 of this bucket. So it create a new object here. And then let's say I call this put operation for the fourth time, and I pass key 4 and value 4. So when I call this put operation for fourth time, it again call this bucket index for key, and please assume that let's say this will return the index as 0 from this hash code because of this hash code. So of course I need to store that into the index 0 here. So entry is actually pointing out here, and in this case entry is not equal to null, so it will go inside the while loop, and then entry dot get key will return the current key that is pointing out by the entry, so which is actually key 1 here, and it compare that with my current key, which is key 4. So key 1 is not equal to key 4, so it won't go inside the if. Then in the else if, it will try to check whether the entry dot get next is null or not. Unfortunately in this case actually entry dot get next is not null, because it is pointing out by the next object of this particular linked list. So of course it won't go inside the else if also, and then it perform entry equal to entry dot get next. It means my entry will come to my second object of this linked list. So now my entry came here, and then again it tried to compare that with key 2 with, I passed it here key 4, so it compare key 2 with key 4. It's not equal, so it won't go inside the if, and then it check that whether in the next there is null or not. So entry dot get next will return null here, so it create a new object and then assign that with the new object here. So in else if it does this job. Let's assume again I call this put operations, but in this time I pass my key as key 4, but value is value 5. So if you see here, key 4 is already present here. So I call the bucket index for key, and I pass here key 4. So this time I'm 100% sure that this bucket index will return here 0, because as the key 4 is already stored there, so of course for this particular key, which is actually stored into the bucket index 0 of this bucket, so this will definitely gonna return me 0 here. So this value is, let's say, 0. And then of course my entry is right now pointing here. Entry is not equal to null. I go inside it, go inside the while loop. I check whether key 1 is equal to key 4. Of course it not. So it go inside the else if. It didn't do anything because the next is not equal to null. So it perform entry equal to entry next. So now my entry is right now pointing here. So now entry move from here to here. In this case also key 2 is not equal to key 4, and next is also not equal to null. So now my again entries come to this particular object. So in this case, if you see, the right now my entry is pointing out here, and this key is nothing but the key 4, and the value is value 5 here. So I compare that with key dot get next, which actually return the key 4, and I will compare that with key 4 itself. So this will matches. In that case, what I does, entry dot set value as value 5. So basically I update this value 4 with value 5. So this is the update operation that I perform whenever the value is already stored. So basically I will overwrite the existing value if the keys already matches in case of put operations. So that's the whole scenario, that actually how the put operation actually works inside the Java library. Let's understand the get operation with the help of code also. So of course I'm performing the get operation. It means I pass the key, and corresponding to that key I should get the value. It means my hash map is already created. That's why I'm applying the get operations. So by using the put operations, I already created this hash map, and now time to call the get. So this is the implementation of the get inside the Java library. And here again I calling the same function bucket index for key. This is the same subroutine, same function I called it in the put operations also. So let's say I call this get function and I pass the key as key 4. It means for key 4, I want this particular value. So I pass this key 4 here in this function bucket index for key, and here again I pass key 4, and I'm sure this function gonna return me 0 because of course this key 4 is stored into the index 0 of this table. So this hash code can return any specific value which is divisible by 16. So let's say it return 48, and then I perform the modulus operator, so this should return 0. So my entry is actually pointing to the first object of this list. So now my entry is pointing out here, and here I pass the value as key 4. So of course entry is not equal to null, and entry dot key, which is actually key 1, is not equal to the key 4. So this both conditions not equal, so that's why I perform entry equal to entry dot next. So currently the entry is here. Now my entry moved to this particular positions. So currently the entries point out here. Again, of course, entry dot key, which actually returned 2, is not equal to key 4. So again I perform entry equal to entry next. So now my entry moved to the last position here. And in this position, as my entry is right now pointing out here, entry dot entry is not equal to null, and of course key 4 entry dot get key return key 4, and it must equal to the key 4 itself because I passed it here key 4. So this has become true. So that's why it's won't go inside the if, and of course entry is not equal to null, so it will just return the entry dot get value. It means it will just return out the value 4 here, and it will return this value, and now this get operation will give me the value corresponding to this particular key. The get operation is comparatively simple than the put operations here. So that's how we have to do the custom implementations of the hash map.